Bismillah, Assalamualaikum warahmatullahi wabarakatuh. And with this opening slide today, which says simplify, I think you know the topic that we will be covering today. It is actually related to simplification. However, before you have your hope high up, I have to make a disclaimer here. This is not about making our calculation simplified. Rather, it is about simplification of force and couple moment system. So we talk about to simplify the system, not to simplify our work. Our work can be more than before, but it will simplify the system, right? So hopefully that is clear. Just like the previous tutorial, the best way to go about this tutorial is actually for you to actually attempt the question while going through the tutorial. You can pause the video at any moment, you can do on your own, and then check whether your method is okay or not, right? So it is best for you to train your brain to work through the question and then see the answer, see the solution, right? That's the best way possible. But regardless, it's up to you how you want to go about in this tutorial. If you need the question, it is already in the PDF file you can obtain from the description box below. So without further ado, let's take a look at our first question for today. Alright, in this question on the left there you have the diagram, and then the question will give you 30 marks. This is from one of the previous midterm, so 30 marks is quite significant. Right, so the question have two parts, part A and part B. So the question says, the three parallel bolting forces act on circular plate. So on the left there you can see the circular plate where you have the three forces FA, FB and FC. So part A, determine the resultant force and specify its location, coordinate X, Y, Z on the plate. FA equal to 1000 Newton, FB equal to 500 Newton, and FC equal to 2000 Newton. This will give you 15 marks. And part B, if the force at A has a magnitude of FA equal to 1000 Newton, determine the magnitude of FB and FC so that the resultant force Fr of the system has a line of action that coincides with the y-axis. This will give you another 15 marks. So as you can see, there's two parts of the question, and the first question is whether you understand what the question gives and what the question wants at the end of the question, right? What the final answer should be, right? So if you look at part A, it already gives you the magnitude of the three forces, and what you need to find is the location of the resultant force. And then part B, not all of the forces is given. FA is given, FB and FC you need to determine, but what you know is the position of the resultant force is already specified, right? So this is related to the simplification, right? So right now, of course, we know the tutorial will be about the simplification of the force and couple moment system. However, in the exam, it doesn't state as such. It just say the resultant force, determine the resultant force and specify its location. So from here you should be able to tell, right? This is simplification, even though the word simplification is not mentioned anyway. So you have to understand the concept. On the second part as well, it will give you the resultant force position. It doesn't give you the magnitude, and the forces only one is given, right? So you need to determine the other two. So hopefully you understand. Okay, this is as well related to the simplification of the force system, right? So we will solve one by one, inshallah. Okay, we will answer part A first. So what is given is FA is 1000 Newton, FB is 500 Newton, FC is 2000 Newton, right? So this is in terms of scalar. If you want to express in terms of vector, so FA vector is, because every force here, if you can see, is in terms of a negative y-axis, right? So in negative j direction. So negative 1000 j, FB is negative 500 j, and FC is negative 2000 j. That is in terms of vector operation, right? A vector expression in terms of Cartesian vector form, right? So what is given is all of these forces, three forces, and we need to find the resultant force. What is Fr, right? N, X, Y, Z coordinate of the resultant force, right? So basically this is simplification and then further simplification to just have one force, right? So that's basically the question. So the question is, what is FR and what is the position? So in terms of FR, it's quite straightforward because all of the forces here is in one direction, right? So FR is simply just additional of all of this. So if you express FR in terms of vector form, you just add all of this, so equal to minus 1000 J minus 500 J minus 2000 J, it should be minus 3500 J, is it Newton? Newton, right? So it is straightforward. This is the resultant force, right? Minus, so does it specify magnitude or scalar? It doesn't say, right? So it's basically this one. In terms of magnitude, it's 3500. In terms of the direction, it is negative y-axis. So that is the resultant force, right? So because of the whiteboard is small for today, I have to erase this to further calculate it, right? So hopefully that is clear, right? And the remaining part for part A is what is the location. So in terms of the location, the concept is this. Because for the original diagram like that, right? So in the final diagram, it's basically just one FR, and there's a location here, X, Y, Z, right? So this is the resultant force, and then you can see over there is the original three forces, right? So the concept is the resultant force here, and if you add all the forces there, it should be the same, and it is the same. As well, if you add all the moment over there, it should be equal to the moment over here, right? Because equivalent system, meaning that it is equal in that sense. The summation of force is the same, summation of moment is as well the same, right? So the concept, based on the concept, means moment, the resultant moment in vector form should be same as the summation of moment in the original system, right? So based on this, you have R cross F for the resultant should be the same as the summation of R cross F from the original system there, right? So that's the idea that you have to understand. All right, so R cross F for the resultant should be the same as addition of all R cross F in the original system, and that is what we are going to do. This is operation, right? Reiterating, so M R equal to summation of M, or R resultant cross F resultant should equal to summation of R cross F. So we have established just now the resultant is minus 3500 J, right? The location we do not know, right? So we assume R is just, the coordinate is X, Y, Z. We just assume as such, right? So if you take the moment about the origin, so it will be in terms of the matrix of this I, J, K equal to R, so it will be, okay, what we know for sure is the force is on the plate. Hence, Y coordinate is 0. If you look at the diagram there, everything is on XZ plane, meaning that Y coordinate is 0, right? So meaning that X, 0, Z, right? Because Y is 0, right? And then FR we have known just now, it is 0 minus 3500, right? It is basically minus 3500 J, right? So that is from here, R cross F for resultant, right? This is the R position vector from origin to whatever location that is. This is the FR that we have calculated earlier. So we have three forces, so we should have three metrics over here, right? So we will not have enough place, so I will try to use space here, right? I, J, K, this is the first matrix, and we focus on point A, FA, right? So for FA, okay, so in terms of the coordinate for R, right? So from origin to point A, so the X coordinate is negative, right? Because it goes to the negative side. So we have negative, and then the radius is 0.45, 0.45, and then cos 45 degrees. Okay, I'm writing like this because I do not have enough space, right? Hopefully you can see 0.45, negative 0.45 cos 45, right? This is not divide, but because limited space, right? In your paper you can write properly. So y coordinate is 0, z coordinate is going down, so it's also negative 0.45, and then sine 45 degrees, right? And then for the force, it is FA just now is 1000, right? So 0 minus 1000, 0. So that's the metric for R cos F for FA, right? So plus the second matrix for FB, right? So you have I, J, K, and then for FB, X is in the positive side, so 0.45, in this time cos 30 degrees, and then 0, and then Z is still downward, so minus 0.45 sine 30 degrees, right? And then force is FB, so 0 minus 500, 0. Okay, so plus the other matrix for FC, so I, J, K. So for FC, the position is straight way up, right? So it is 0, 0, 0.45, straight way up with the radius of 0.45, and then force is 0 minus 2000, 0. So we have R cos F for the resultant, and then R cos F, summation of R cos F, R cos F for FA, R cos F for FB, R cos F for FC, right? So right now it's just mathematics, right? So we can you have understand from the diagram over there how to get each of these, right? And from now on you do not need the diagram anymore, so I can use that part of the whiteboard, right? So on this part, on this side, you can solve this one. You will get for I, okay, I'm solving this side here, right? So this is the limit due to the limitation of the whiteboard size, right? So in your paper it should be properly aligned, right? So on this side, so I'm writing with a red color here. For I, you have 0 minus negative 3550, so becomes 3500 Z, right? So for I, this minus this, right? And minus this, so okay, it becomes 3500 Z. Okay, minus J, J becomes 0 and 0, so 0. Can you see the red color? Hopefully you can. Plus K, K, so here, so this minus this one, right? So minus 3500 X. So on the left side of the equation you get this one here, right? From here, from the right side, so from here equal to this whole thing, so we will solve one by one. So on this one, for I, what you get for I, this is 0, this is, if you multiply this one, negative, negative, so minus, what will you get? So you can verify these numbers, right? 318.2, 318.2. This is from this number, yeah? 1000 multiplied by 0.45 sine 45. And then minus J, 0 and 0, plus K, so this number minus this number, right? This number will give you 318.2. 318.2 is the same number because sine on cosine 45 is the same. Alright, so on this one, plus I, for I, 0 minus this number here, so if you calculate this one, you should get 112.5. So 112.5, right? So why is it negative? Because this negative become positive, but this minus this, so that's negative there. Minus J, it should be 0 because 0 minus 0, plus K. Okay, plus K, so you have this minus this one. So this one will give you, because there's negative there, negative, and then 194.86. Right, going here, plus I, so 0 minus this one, because the negative there become positive then, so this become 900, and then minus j, you have 0 because 0 and 0, and then plus k, you have 0 as well because 0 and 0, right? So from these exercises you will get this red one, right? So this equal to this one, right? From there I think you can solve, right? Because you have the equation for I, and then you have equation for k, right? So from all of those calculation, if you calculate, you should be able to get, so where should I write? So you can verify the calculation, so please check whether you can get. So remember, the question asks for resultant force, which we have expressed, and as well as the coordinate. Specify its location in terms of x, y, z. So x is here, what you can calculate until the end. Z is here, right? So in terms of the coordinate, please verify the number. You can calculate until the end. You should get minus 0.035, and then 0, and then 0.134 meter. So that will be the coordinate of the resultant force. Okay, is it clear from the lighting there? It is becoming unclear, is it? So okay, if not clear, I'll just repeat verbally, right? Minus 0.035 for x, and then 0 for y, and then 0.134 for z, right? So that is the answer, right? So that is part A, where you get your resultant force and the coordinate. So I will erase this for part B, inshallah. Alright, so going to part B, what is given? What is given is FA is still 1000 Newton, FB is unknown, FC is unknown. So in terms of a vector expression, so is this clear in terms of the writing? So in terms of vector notification, so in terms of Cartesian vector, so FA will be minus 1000 J, FB will be minus FBJ, it is unknown, FC equal to minus FCJ, which is also an unknown. And what you know, okay, do you know FR? Still you don't know, right? Because that information is not given, right? But we know actually the coordinate, right? The coordinate of the resultant, where the resultant force act. The statement says FR has a line of action that coincide with the y-axis, right? Meaning that x, y, z will be 0, 0, 0. This is where the force is exactly on the y-axis, right? So we know that already, right? Hence what we know is the R for resultant, right? It should be 0i plus 0j plus 0k. If we take when we want to calculate the moment after this, right? Because it is actually the origin, so it's 0. The position vector is 0, right? So the concept is just the same as before, right? What we will do is the moment of the resultant in the equivalent system should equal to the summation of moment, or R resultant cross F resultant equal to summation of R cross F for the three forces in the original circumstances or system, right? So but if you ask, but we do not know FR, not to worry, because when you express after this, you will see why that's not a problem, right? So we will use the matrix as before. Okay, right, based on this, right, and we already know what we want, which is R cross F for resultant equal to summation of R cross F for the system over there, right? So R cross F for the resultant will give you I, J, K. Right now is, as we mentioned, R will be 0, 0, 0, right? So F R X, F R Y, F R Z. So you can see from here why this is not important, because the moment will be 0. And that's logical as well, because Fr going to the origin, if you calculate moment about the origin, obviously it doesn't produce any moment, so it will be 0. On the right side, so we will have just like before for part A, it's just that the force is unknown, right? So it will have I, J, K. So for Fa, so again it's negative, so negative 0.45 cos 45 degrees, 0, and then minus 0.45 sine 45 degrees. Hopefully by now you understand this already, right? This is, again, if you have to recall back trigonometry, etc., do go back to the video, right, for trigonometry. Okay, and then for Fa is known, it's 1000, right? So 0 minus 1000, 0. This is exactly part A, right? No, oops, no changes here. And then plus for I, J, K. This is for FB right now. So for B, this is 0.45 cos 30 degrees, 0 minus 0.45 sine 30 degrees. Why minus? Because it's downward, right? And then force is 0 minus FB 0. We do not know the force, right? And then plus for FC. So I, J, K. For the position vector is straightway up, so 0, 0, 0.45, and then 0 minus F, C, 0. Right? So right now we can straightway calculate as before as well, right? So you do not need to look at the diagram as well as anymore, so I can use that side. So here you can see that this, if you do I 0, 0 for J, 0, 0 for K, 0, 0, is basically just 0I plus 0J plus 0K on the left side. On the right side, so on this one is the same, right? So I will be 0 minus this one, so it will be still 318.2, right? And then minus J, this is 0 plus K, so this minus this one, so you'll get 318.2, right? 318.2. And then for this one, plus I, it will be 0 minus this one, so basically you'll get in terms of FB, so you get minus 0.225 FB. Alright, so minus J, you have 0, plus K, for K you have this minus this one, so in terms of FB as well, so minus 0.3897 FB. Right, and then going here, so plus I for this one, so 0 minus this one, so it's straightway 0.45 FC. So minus J, you have 0, plus K, you have 0 as well, right? So from here you can see that for I you have equation I, J, everything is 0. For K you have K, 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 and K, right? So you can do simultaneous equation as well, just like before, and finally you can solve for what is FB and what is FC, right? So FB, if you solve, you'll get 816.5 Newton. So for FC you get 1115.4 Newton. Right, so again, FB 816.5 Newton, FC 1115.4 Newton. Right, so that's basically how you solve this question from the previous midterm, and hopefully everything is clear, right? So even though the question did not specify this is simplification or further simplification, you have to be able to decipher that, right? Or this question will use that concept to get those position or those forces. Hopefully everything is clear. If not, just comment down below where it's not clear. Inshallah, we will move to the next question. All right, now if you have the PDF you will see this slide. It says interconnected. What does this mean, right? So it means that in the exam, sometimes the question is interconnected between different chapters, right? So let's take a look at this one. This is from one of the previous midterm question. It have the diagram on the left, and the question which says replace the loading acting on the beam by equivalent resultant force and couple moment acting at O. So we know from the question this is equivalent system. Part B, replace the loading acting on the beam by a single resultant force. Specify where the force acts, measured from O. So again, we know this is a simplification, right? However, if you look at the question in the diagram, it does involve distributed loading. Hence, it combines different part of the chapter, right? And if you follow the courses at this moment, you haven't covered yet the distributed loading, because that is the next part. And hence, this question we will discuss in the next tutorial, inshallah, because it does involve solving the distributed loading first, right? So it is interconnected in terms of the question. It will connect different chapters, different sub-chapters, etc. So for this tutorial, we cannot answer this question from the previous exam, because we need to first use the distributed loading first, right? So we will move on to the next question, inshallah. Alright, so if you have the PDF again, you will see this slide, right? It says everything is possible, the impossible just takes longer. Now, why suddenly I have this slide? Okay, to put in context, normally if you are my student, you know this, I will try to cover all of the actual past exam questions, and we have done that so far for the tutorial that we have covered so far until now. Until the previous two questions, one we can solve, one we haven't been able to solve yet until next tutorial, right? So after I have searched all of the previous exam that I have in store, there's no other question that involve simplification which we're covering today, right? So why is that? Is that the meaning that can we say that the trend is this chapter is not popular in the exam, right? So there's a reason for this, because normally chapter 4 until now it will be tested in the midterm. However, if in any particular semester, by the time the midterm, some of the section have not yet covered until this point. So it is not fair to test the student on this one. So sometimes in chapter 4 it is not tested up till simplification. Hence, that question becomes less popular because of that reason. Alright, so it doesn't mean that it will not come in the exam. It just means that in terms of the storage from the previous semesters, unfortunately, we don't have that much question for this particular topic, right? So, but still, if you go to the slide again, everything is possible. Do not think that because previously this topic is not popular, it will not be coming in your exam, right? Everything is possible. Everything is possible. However, for the purpose of this tutorial, I will select just additional question from the textbook so that we can solve here just in case some question come up, and just in case, because you need to be prepared as well, right? So from the perspective of the actual real exam question from the past, that's the only question, the previous one. So what will come next is some sample of question that is possibly the exam level, and it is possible to be tested on this. So we will move on with one or two other question, inshallah. Alright, now let's take a look at this question here. You have the diagram there, and then you have three parts of the question, right? So part A, replace the loading system acting on the post by an equivalent resultant force and couple moment at A. And part B, replace the loading system acting on the post by an equivalent resultant force and couple moment at point B. And question C, replace the loading system acting on the post by an equivalent resultant force and specify its location measured from point B. Alright, so hopefully you understand the question, right? Part A and part B, you want to replace by an equivalent force and couple moment at different point. Part A is, question A is part A, point A, sorry. Question B is at point B. And question C is further simplification, only one force and specify where it is positioned, right? So without further ado, let's solve this question. Okay, first, hopefully you understand the concept already, what we want to achieve in the end, right? We want to achieve just at that point, in point A, for example. For question A, we want equivalent force and couple moment at point A, meaning that this is point A, right? So basically in the end, is it clear? We just want to have one FR and, for example, one MR. That is the goal, that is the aim, right? We want to know, okay, the equivalent of one force and one moment at point A, what is the force and what is the moment? That is the purpose of this question. Alright, so if you look at the diagram there, so we have forces and we have one couple moment there in blue, right? So in terms of getting FR is quite straightforward actually, right? So if you use scalar, okay, in the previous question, in the first question of this tutorial, we have done already vector operation. So this one we will try to use scalar because it's 2D, right? So FR, so if you use scalar, then you have to resolve into X and Y, right? So FRX should be just summation of all forces in X axis, in X direction, right? So if you do this, if we take, like, say, positive to the right, so we'll have the 650 becomes 650 sine 30 degrees, right, to the right. And then 300 doesn't have any X component. 500, it is to the left, so negative 500 cos 60 degrees. Okay, this marker, hopefully you can see the writing. Okay, so that's the X component that is available. If you calculate this one, what do you have? You have 75 Newton. This means it is to the right. Okay, then you do for FRY. If we take upwards as positive, it should be summation of FY, right? So if you take upwards as positive, then in this case everything will go downwards, so everything is negative, right? So we will have negative 650 cos 30 degrees, negative 300, negative 500 sine 60 degrees. Yep. What else? That's all, right? So if you do this, you will get minus 1295.93 Newton, right? So that is what you get. Now what does this mean? This means is that the X component is 75 Newton there, and Y component is 1295.93 Newton there, right? So meaning that the resultant force FR is here, and let's say theta is there. If you draw like this, then FR is simply okay, FR is simply just square root of this 75 square, and then this 1295.93 square. And if you calculate this one, can you still see this part? Okay, you will get 1298.1 Newton. That is FR, right? And what is theta? Theta is tangent negative 1. So in this case, 1293.95. Sorry. So this value here, right? 1295.93 over 75. So if you calculate this one, theta, you will get 86.7 degrees, right? So that will be your resultant force. Now remember, if you are doing in terms of scalar, even the question doesn't say what is the angle, etc., you have to specify resultant force as well as the theta, because otherwise then you do not know the direction of the force is where, so the answer is incomplete. So you have to specify as well the theta. And remember, in the lecture I do mention that you have to specify that theta is in which quadrant, right? In this case it's quite clear because you already draw theta is in this quadrant, hence this value is in this quadrant. If you have no diagram here and you have no indication this is in which quadrant, then you will lose out in terms of the mark, because that is not a complete answer. So make sure you remember that. Okay, this is the part of the force, but in terms of the equivalent force and moment system, you have also to have the moments, right? So now I will erase this to calculate the moment. Now calculating the moment, right? So it is now part A is about point A, right? So basically, so moment of the resultant about point A should be equal to summation of moment about point A, right? That's the equivalent, meaning that moment at point A that we want to draw in the end is equivalent to the summation of moment of whatever is in the question in the first place, right? So if we take counterclockwise as positive, right? So summation of moment equal to, so basically this is MRA counterclockwise, right? So from the left, 650, we take the vertical, because every horizontal component will not create any moment about point A or B for that matter, right? So the vertical one for 650, so it will produce counterclockwise force, so it's positive here. 650 cos 30 degrees. This have a distance of 3 meter from point A, right? Now 300 Newton goes straight to past point A. It doesn't produce any moment, or the distance is 0, but you have that plus 1500 Newton meter, right? So make sure the unit is tally, right? This one is Newton meter, this one is Newton meter, so it is consistent. And then 500 Newton, so that 500 Newton is clockwise, right? So negative 500 sine 60 degrees. The distance is 5, and then that's all the forces, right? So if you calculate this one, you will get 1023.686 Newton meter, right? So basically what it means is, at point A you have already established the FR just now, right? It's basically something like this, FR with the value that we have calculated. Now this moment, what is the direction? This is positive, meaning it is counterclockwise, right? So it is counterclockwise here, MR, where this one, the value we have already established just now. What is it? 1298.1 Newton. This one is 1023.686 Newton meter, right? And normally when they round up to get three significant number, they will go into kilonewton, right? So it will become, basically, if you convert to kilonewton and round to three significant number, you will get 1.30, right? 29 becomes 30 kilonewton. This becomes 1.02 kilonewton meter, right? If you see the textbook, they will finally get this answer here, right? Because they want to be consistent with the concept that we have covered in chapter 1, which is to get only three significant numbers, right? So that is for part A, right? So going to part B, inshallah. Okay, now solving for part B, we need to in the end have at part B, at point B, right? So what is FR and then what is MR, for example, right? However, in this one, if you want to calculate FR, it will be exactly the same calculation and the same answer from part A. So I will not repeat this one here, right? You will in the exam, you can just either repeat the calculation or just say same as part A, and the answer will be 1289.1 Newton, and then the theta is 86.7 degrees, right? So that's the final answer for FR, right? So it's just the same. The difference is in terms of MR, because the moment is at a different point, hence the distance is different, the rotation is different. So we'll straightaway go and calculate that one. So the same concept as before. MR is just summation of all the moment about point. Now it is point B, right? About point B. So if you calculate this one, let's take counterclockwise as positive as well. So MR about point B. So from the left, 650. So basically you have counterclockwise. So 650 cos 30 degrees. Now the distance to B is 3 plus 5 plus 2, 10. Right? Distance to point B. And then the 300. So counterclockwise as well. So plus 300 the distance is 5 times 2 is 7, and then plus 1500 from the couple moment there in the blue, and then plus 500 sine 60 degrees with a distance of 2. Right? If you calculate this one, you will get 10095.2 Newton meter. Right? So meaning that Fr is the same for the magnitude and also the theta. Mr right now is 10095.2 Newton. Right? Or if you convert into kilonewton meter, becomes 10.1 kilonewton meter. Right? So that is part B. Right? So if you understand part A, it should not be different or difficult to settle for part B. Right? So going on to part C, inshallah. Okay, in terms of part C, the question says what is the equivalent resultant force and specify its location measured from point B. Right? So normally when we do further simplification from, and we want to have the distance from a certain point, it's just continuation of this one, right? So what it means is, if you still remember the concept, we know already that here is Fr, and then this is counterclockwise, right? So Mr about point B here, right? So what is this distance here, right? So that's the only question, because when we say, but you have to still specify, the Fr is the same, so just take the answer from part A, and hopefully you will get it right in part A, right? Hopefully, because if you make a mistake for part A here and you get the wrong Fr, and then you continue using the same and the same for part B and C, unfortunately you get it wrong, right? Yeah, so make sure you get it right, because it will affect the whole thing. Okay, so in this case, the concept is what? moment due to this distance should equal to this Mr, right? So basically Fr, so if you use this one, Fr is already known as, what is the answer from the first one? It is 1298.1, and then theta, you have here theta is 86.7 degrees, right? So moment about this point B should equal to moment there, which is this one, right? So moment here, which is force, perpendicular force times distance, right? Perpendicular force is 1298.1 vertical sine 86.7 degrees times distance should equal to this one, right? 10095.2. Can you still see this part? Hopefully you can. So from here you can calculate D, 7.79 meter. So that is the distance, right? That's not only the answer, because the answer is what is the equivalent force and what is the distance. This is the distance. Equivalent force is this one, right? So you have to actually say equivalent force is, as calculated earlier, is the same. Fr is what, theta is what. You have to provide that too, and then the distance is this one, right? So I'm not repeating the concept from the beginning. Hopefully you have understood that from the lecture. If you haven't, what is going on, go back and watch the lecture first, because this tutorial assume you already have covered the lecture first, right? Alright, so we will go into another question. Okay, now take a look at this question here. You have the diagram, and then the question says, replace the force system by an equivalent resultant force and couple moment at O, at point O. Take F3 equal to minus 200I plus 500J minus 300K. So if you look at the diagram, you have F1, F2 and F3. F1 is already given in the diagram, 300 Newton going downwards. F2 is already given also 200 Newton in the y-axis direction. And F3, it is already given in the question in terms of Cartesian vector notation. Right? So based on this question, you have the diagram, and you have to get what is the equivalent force and couple moment at point O. Right? So in the end, the structure, and at point O you have Fr and Mr. So how to get that Fr and Mr? So you have to understand that. So how to calculate? Quite easily, because What you need is just FR and MR, right? And this is in 3D, so we'll use a vector notation, right? So what is FR? It's just summation of all forces, right? So basically, quite simply here, F1 is 300 downwards, so it is minus 300 K, right? Or 0I plus 0J minus 300 K, right? Should I write right then? Okay, let's write in that way so it is clear and we avoid mistake. So 0I plus 0J minus 300 K, right? So F2, sorry, this is F1, right? What is F2? F2 is, it is Y, right? So 0I plus 200 J plus 0K. What is F3? Is given in the question, minus 200I plus 500J minus 300K. So what is FR? Is the summation of all of this. It is 0, 0, okay, minus 200I plus 700J minus 600K. What is the unit? Newton. So that is FR straight away. Now, what about MR? So MR, so this one is understood because we have to find FR and MR. So FR is settled. What about MR? Alright, so MR, how to calculate? MR about 0.0, right? Because the question says it is about 0.0. So you take moment about 0.0. So it is just the summation of R cross F, right? R is from 0.0 to where the force is, right? So let's do one by one. So for F1, you'll get I, J, K. R will be, for F1, it's 0, and then 2, and then 0, right? And then the force is 0, 0 minus 300, right? For F2, I, J, K. R is 1.5, 3.5, 0. And then force is in Y, right? 0, 200, 0. And then for force 3, so X is, I, J, K. Rx is 1.5, 2, 0. And then F is minus 200, 500, minus 300, right? Oops. So if you have established that one, then you just calculate afterwards, right? So this equal to, for I here, you can see this one, hopefully you can. So this one is minus 600, minus 300, minus 0, right? So minus J, 0 and 0, plus K, 0 and 0, plus I here, 0 and 0, minus J, 0 and 0, plus K, what is this? 300, is it? Okay, and then here, plus I, minus 600, minus J, minus 450, right? K plus K, K. So this is 750 minus plus 400. Right, so basically the rest is just to complete the calculation, right? So basically for I, you'll have minus 600, 0 and minus 600, is it? So it becomes minus 1200I, right? And then for J, 0, 0, minus 450, minus 450J. For K, 0, 300, 300, 700, 1450, right? Plus 1450 K. What is the unit? Newton meter. Right. So that is the answer. So we have established FR before, we have erased it, and now we have established MR. So that's the end of this question. So it's quite simple, right? Obviously in the final exam, if it comes in final exam, it will not be as simple as this perhaps. Maybe in F3 you have to use alpha, beta, gamma, or coordinate, direction, angle, etc. perhaps, right? So it may combine different chapters, right? But the concept for this part in terms of getting equivalent force and moment is just as such, right? So that is for today. Alhamdulillah, alhamdulillah, for simplification of moment and couple force and couple moment, and also further simplification to get just single force and specifying its location. All right. So I'm not sure if you notice the position that I am in. And this whiteboard, this is much smaller than previous tutorial because we have issues with the whiteboard. They take it back and they will send it back hopefully soon. It is not soon enough for this tutorial, so I have to use the children's whiteboard here. It is much smaller, and the location is, I'm actually sitting down right now. If I'm standing up, it will be like this. So yep, so that is it. Thank you for watching. Hopefully you have understood the concept and how to solve, and hopefully you appreciate the effort. Do like the video, it will help in terms of the YouTube algorithm. Thank you very much. Hopefully you understand the concept. That's the most important thing. Any question, do ask in the comment section below perhaps, and I will try to get back to you inshallah. Wallahu alam, subhanakallahumma wa bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh. See you next time. Oh yeah, one more thing. This is the first time ever that I have, since the last time, since last semester I think, when I recorded the lecture video. This is the first time since then that I have been recording in the late midnight. This is actually 1:37 AM, right? So this is, where is it? Okay, yeah, so this is 1 AM. I have just finished the recording. I have to actually go to computer to edit and then upload for you inshallah. So hopefully pray for me, so that this effort will be rewarded by Allah subhanahu wa ta'ala inshallah. And of course, for the video, if you haven't liked already, please do like, it will help. Wallahu alam again. Wassalamualaikum warahmatullahi wabarakatuh.